So today we're going to look at some more simplifications of rational expressions. Now we've learned how to subtract them and add them, as well as divide and multiply them, right? So I thought we'd look at one to begin with. It's a little bit more involved because it has three pieces, or three fractions, three rational expressions that we'd like to combine. If you have 3 or 4 or 5 or God knows how many, you do the same thing. Surprise, surprise. So you see anything that like makes your leg want to twitch a little bit. You're like, my reflex, it just wants to kick in and change something into something else. Yes, right there. Your leg should just be going, I have to go like over here and change that. Difference of squares. Get my shot. Alright, so we factored the bottom. What should I do now? I should search. So this one's missing something, yeah? Missing x minus 3. And it's also missing another x. Where's Mary saying that it needs another x from? It already has plenty of x's. Because it needs that as well. Oh, so is this one finished totally? It needs that x as well. Multiplying, of course, because why am I allowed to do this again? The clever one, yeah. So now there's one other thing I think that's missing at least. All three pieces don't have a common denominator yet, right? Like, this needs x plus 3 and x minus 3. So now on top, you know, instead of writing the factors on top, I'm going to think ahead a little bit because I'm going to be wanting to combine like terms, right? So what should I put up here? I do. Thank you, Lauren. Good mistake you caught. And then over here I need to do this on top as well. I'm just going to say x squared minus 9 because that's really the same thing, isn't it? And I'm thinking ahead a little bit so I can save myself some writing because I don't like to waste markers. Where's the other mistake? Right here. Very good. We're good now? You guys are very skeptical about my work so far. I'm glad. I think we're good. So now let's have all the common denominators. You can smash them all together. So the common denominator is x times x minus 3 times x plus 3, and then we just see what we have. So it looks like we have negative 4x, and here I'm going to distribute. So that's x squared minus 3x. 1 really doesn't matter, right? And here I've got plus. I'm watching out for minuses because I don't want to make that mistake. It looks like we're all good to go there. Any other questions so far? I'm happy because I only see like quadratic terms. I don't see any cubic terms. That could happen on some of your problems, so don't be afraid of it if it does. But I'm pretty happy that it didn't. So combining like terms, looks like I have like this one, this one. So that's going to be 2x squared. And I've got minus 4 and minus 3, or negative 7x minus 9, all over x times x minus 3 times x plus 3. Now at that point, you've done most of the problem. So if you're like on the quiz at that point and that's how far you get, you're going to get at least like 3 out of 4 points. But especially if it's like this, you should be like feeling your leg kicking in again. It's like I see something that I could like do something with, probably. What am I talking about? The thing on top is probably factorable. Unfortunately, it has the 2. Do you guys want to try to guess and check it going back to yesterday, or would you just prefer to use the little process? Okay, so who wants the process? Don't be afraid, we all got our preferences. Let's do this with the democratic rule. So who wants the process? Come on. Gotta pick one or the other. 2, 3, 4, 5, 6 or 7. Okay, who wants to guess and check it? Oh man, I think the guess and checks it have it. So we'll do the process on another one, okay? So I think I've got another one in here we'll need that for. So guess and check it has it on this one. You know, I'm not surprised. You guys are pretty clever people. So let's try that. So it's nice to guess and check at least because it's only a 2, right? So that means that if it's factorable, it might not be, all right? Like there might be no way to do it. But if it is factorable, then 2x and x is going to have to do it. 9 is not super simple, but it's not too bad because it only has factors like 3 and 3 or 9 and 1. So what do you guys think? How can we get -7 to work? So one of them is going to have to be negative, right? So what if we went 3 and 3? Should we just try that first? Or not? Think ahead. Mary says she doesn't think 3 and 3 is going to work. Because you could get like 6x and 3x. Is 6 and 3 somehow going to give you 7? I don't think so. Is 9 and 2 maybe somehow going to give you 7? Somehow so. But it's not 9 times 2 that equals 9. It's 9 times 1. So maybe we should go the 9 here or here. Think ahead. If you put it here, you're going to get 18x. That's too much. So put the 9 here. That means the 1 has to go here, and now we got to decide, do we want more negative or more positive? Looks like more negative, so probably put the negative here and the positive here, and now check. Now I thought a lot about this guess and check. When you do guess and check, do you have to think about it that much? No, but that's the way you should be trying to go. You know what I mean? If you're going to go guess and check. So did this work? 2x minus 9x is -7x. 2x squared minus 9. Bam, that's the answer. Okay, so if you're not always going to get it to come out that fast. You're going to have to play with a couple guesses and then be like, foil in your head or foil on paper over here. That's really a good thing to do, to try to foil these in your head as well, because that just makes you stronger. It makes you stronger. You'd be good at a lot better at other things as well. But you know, I had trouble with that in high school, so if you do, don't be afraid to use the process. Okay, did that help us on this one? No, because we couldn't cancel anything. But is that still a thing that you should probably be able to do? Of course, because in calculus and in this class, we're going to be graphing these guys and using them to do different things, and you need the top factored for certain reasons. Like, that's where the x-intercepts are for this graph. It's where the top is 0. So we'll be doing that next week. Okay? So that's, I think, as far as that problem goes. All right, so let's get it out of the way and look at a couple more. So here's another one with 2 pieces. I know I'm going to have some legs tingling on this one because that's something that we just factored. So leave the original parts in black. And then this one I think you can factor easily too, right? What is it? X plus 3 and x plus 3. You could write that as x plus 3 quantity squared if you want, but I'm not going to. Common denominator is what on this one?
X plus 3, x minus 3.
Yeah, you need 2 x plus 3 quantities because that needs both of them, right? So does this one have enough of them?
No.
It does not. This one needs another x plus 3 times, right? And this one clearly needs an x minus 3. Yes. So I'm going to wrap that in parentheses. All right, so let's see what happens. The common denominator is x plus 3 quantity squared, and we got an x minus 3 quantity as well. Do some distributing business, so we're going to have this. It's x squared plus 3x. And we're going to do all that stuff, you know, this and this. So you're going to get plus, watch out for minuses, x squared, 1x, and minus 3x is minus 2x. And that is minus 3. All right, so on top we have 2x squared. This is looking like the other one. Minus x minus 3.
Plus x.
Do I have a mistake?
Plus x.
3 minus 2 is plus. Yep. Should we try to factor that one? I don't know if it does. I think we will all use the process on this one. I'm going to do it quickly. So let's see. 2x squared plus x minus 3 minus 6. 2 and 3 minus 2. Then I'm going to go 2x squared minus 2x plus 3x minus 3. They share 2x. These share 3. Yes, it does factor because those share x minus 1, the quantity. If I put that on top, though, will I get anything to cancel on this one? No. So again, for purposes of simple mechanical stuff, mechanical algebra, I kind of wasted my time. But you're not going to know that in advance. So get in the habit. Feel your legs start to tingle. Okay? Let's look at another one. All right, so 2 more problems. These ones don't say add or subtract the rational expressions. They say, like, divide them, right? So on the first one, I think I'm ready to divide right away because I just have one piece on bottom and I have one piece on top. You can start factoring stuff right away, or you can flip right away. It's your choice. What do you guys want to do? I heard flip. You guys are like, I just want to be done. Have some patience. Okay, so let's do it at the same time. We're lazy. We don't want to write a lot of stuff down. What's this factor as? Help me out. 8 and 4. You guys are so quiet, Ashlyn. Speak up. I heard you, but no one else did. Is that right? 8 and 4 is 12 times 32? Yes. Okay, what about on the bottom? Can this be factored? They share 6. What's left is x and 7. Now we're going to take this guy and multiply by the reciprocal with a nice copy dot flip. We're not going to even write them separately because we can just smash them together right away, right? So this is going to go on the top. That's, of course, x plus 7, x minus 7. We're starting to get the volume up there. I like it. Okay. And then this guy is going to go down here. I think you can do a little bit with him as well. They share, no, that's not difference of squares. They share x, so you'll have an x plus 2. Does that make sense? Make a nice times in there if you got space, just to be clear. And I think quite a few things cancel, don't they? Oh, it's a 4. You're right. Thank you. There we go. Okay, so gone. Is that it? I think so. So what's left is x plus 8, quantity x minus 7, and 6x on the bottom. Cool? Okay, now some of you are going to be tempted to like expand this back out. Having things factored lets you see all of the essential stuff for graphs and for other things. So factored is better. If, of course, you wanted to expand this out, you could. There's nothing wrong with that. You could x squared 8x and minus 7x is x. Minus 56 over 6x. But I just want to make sure that none of us do this. The horror. The horror! Why can I not do that? Because I no longer have a product. Yes, there's only one thing on the bottom, which means it is ripe for cancellation. But on the top, no way. These are 3 separate things. There's no product or division up there, so I cannot cancel that out. So don't be tempted. Just leave it back here. Mary.
When you did the copy dot flip, they didn't have the same denominator.
Do they need to have the same denominator? If you have, let's just think about it. That's a good question. So what if we had 1/3, let's just go to easy numbers, like 1/3 divided by 1/6. Those don't have the same denominator either. Let's just think about this in our head. If you have a third and you divide 1/6 into it, what's the answer going to be? Forget about the algebra. If you have a third and you divide it by 1/6, how many times does 1/6 fit into 1/3? Twice. It fits in twice. 1/6 fits inside of 1/3 twice. If you're unsure about that, think about a pie. And you have 1/3 of the pie. Yes, I know my pie is wonderful. So 1/6 of the pie would be like if your pie was cut into 6 pieces. But you can clearly see, how did I decide to cut that into 6 pieces? I looked at 1/3 of the pie and I cut it straight up in half. So there's 2 1/6 and 1/3. So that should mean that the answer should be 2. So if we do what Mary was asking about and go copy, dot, flip, what's that reduced to? 2. So I think it's okay, even if the denominators are different. I don't know if that's proof, but does it do it for you guys? I hope so. Good question. All right, let's do this last one for today. So, you guys tell me. I need common denominators. More than one? Yeah, I need to do it on the top and the bottom. On the top, there's something I can do first. What's this one need? Yeah, in order for them to be the same, make it a legal, clever one. And on the bottom, those are actually totally different. Some people are going to look at these and be like, well, they both have an x and they both have a 2. They're pretty the same. They are totally different. They each need the other one. X minus 2 here. In fact, you know, this is getting too crazy. Let me go to another color here. This needs x minus 2. Make it legal. And this needs x plus 2. So that looks pretty cluttered, but I think this is going to boil down nice. So I'm going to say, all right, on top I have x plus 2, x minus 2. If I distribute here, I need more colors. Then I'm going to get what? 3x and 6. When you're doing complex fractions like this, where you have fractions inside of fractions, possibly, potentially inside of other fractions, make sure you're clear about where the main fraction bar is. That really matters when things start to get a little bit ugly. This is actually a pretty easy problem, and you guys will think so if you do your practice. As long as you keep track of where the main fraction bar is. Yeah?
That's minus 6.
Is it minus 6? I think I went 3x. This is minus 6.
Oh.
Got me?
Yes,
Thanks.
I got it.
I wasn't finished yet. I had an aside. Perhaps I should have waited, Kyle. Sorry, man. Okay, so then on the bottom, we've got that same common denominator. If we have a thing on top and the bottom that have the same common denominator, what do you think is going to happen to the denominator? If you divide 3 by something, and then you divide pineapples by something, if you divided them both by the same something, the division is irrelevant. We'll see why that is here in a moment. I don't know if that was the best conceptual explanation. My choice of pineapples was tenuous at best. So let's continue distributing. I like exotic fruits. I'm going to pick like lychees or something, or durian next. Some Asian fruits. Then 1 is boring, right? This is just going to be plus x plus 2. Watching out to make sure that this is not a minus. Okay, so I can combine some like terms now. So those go away, right? So that's just 3x over the denominator. Main fraction bar. And then on bottom I have 4x's minus 4 over that same denominator. So you can always have a couple different options at this point. If I have one fraction over another fraction, just like I did back in the day on that problem, what did we do? We flipped it. We did copy dot flip and multiplied by the reciprocal. You can do that here. Think about what's going to happen on this problem when you do that. And you go. Think ahead.
It messes up your
like the denominators are going to totally cancel out, right? That's what I was trying to say with the crazy pineapple example. Is if you have one thing and you divide it by 3, and then you have another thing and you divide it by 3, you really just have those things divided. The dividing by 3 part is irrelevant. So really on this you can, if you'd like, just go chop. If you don't like that, cool. If you really don't like that and aren't comfortable with that, don't do it. Take another step. My arm doesn't bend that way. And flip it. And you'll see that that clearly cancels. Okay? So this is going to simplify down to 3x over 4x minus 4. If you're like, but I thought like this thing flipped and like was somewhere else. Keep track of my fingers. Top finger means this goes on the bottom. It's on the bottom. Okay. And can we do anything there? Actually, yes. If you go like this, bad mojo. Because there's a blocker. That linebacker just took you out. But you can say, oh, they share a 4. So this is x minus 1. I guess that didn't help. I was hoping the x's would cancel, but they don't. Darn it. But that is the best form, the simplified answer of that complex fraction. If you'd like to see more videos, there'll be another one following this one. See you then.